Good morning, everyone. I am Professor Swam Reddy from SR University. In lecture 3, 2 and 1, we discussed about Laplace transform and calculation of Laplace transform using first shifting theorem, division by t, multiplication with t, and Laplace transform derivatives, Laplace transform integrals, and etc. Now, in lecture 4, we are going to discuss inverse Laplace transform of some standard function. Before that, what is inverse Laplace transform? Here, f bar of s is the Laplace transform of f of t. Then what is say the Laplace transform of f bar of s, and it is denoted by L inverse of f bar of s is equal to f of t, not bar, f of t. So then what you say, f of t is the inverse Laplace transform of f bar of s, right? Just inverse. If you take the Laplace transform 1, what is Laplace transform 1? 1 by s. Then the inverse Laplace transform 1 by s is 1. Similarly, the Laplace transform of t is 1 by s square. Then the inverse Laplace transform 1 by s square is t. Similarly, the Laplace transform of, what is the Laplace transform of sine at or sine t? Sine at is a by s square plus a square. Then the inverse Laplace transform of this a by s square plus a square is equal to sine at. Yes, a, the constant, send this side. So the inverse Laplace transform 1 by s square plus a square is 1 by a into sine at. 1 by a into sine at. Right? Now the linear property of this inverse Laplace transform. Inverse Laplace transform f bar of s is f of t. Then the inverse Laplace transform constant c1 and c2, two constants, into f1 s bar, f2 s bar is equal to c1 into inverse Laplace transform f1 s bar plus c2 into inverse Laplace transform f2 s bar. This is the linear property, right? So this is a proof. Already we discussed in the linear property in Laplace transform. Similarly, here inverse Laplace. The constant Laplace transform is constant into Laplace transform f1 t, and constant into f2 of t is c2 into Laplace transform f2 of t. Similarly, f1 of t is equal to inverse Laplace transform f bar of s, and f2 of t is inverse Laplace transform f2 bar of s. Just you substitute here. Therefore, c1 into the Laplace transform and inverse Laplace transform gets cancelled. So the Laplace transform c1 f of t plus c2 f of t is c1 f bar of s plus c2 f bar of s. Or if you take the inverse Laplace transform, inverse Laplace transform c1 f bar of s plus c2 f bar is c1 inverse Laplace transform f bar of s plus c2 inverse Laplace transform. This is called the linear property of inverse Laplace transform. Right? Now, some standard functions inverse Laplace transform we will discuss now. You know the Laplace transform of t power n. What is the t power n Laplace transform? The Laplace transform of t power n is n factorial by s to the power of n plus 1. In lecture 2, we discussed the standard functions Laplace transform. Now, in lecture 4, we are discussing here the inverse Laplace transform standard functions. Now, this is n factorial is a constant, right? Now, the inverse Laplace transform n factorial by s to the power of n plus 1 equal to t power n. So, the inverse Laplace transform apply only this s functions, right? So inverse of 1 by s to the power of n plus 1 is equal to n factorial is n that side. T power n by n factorial. Right? T power n by n factorial here. Right? Is apply only for this S functions. Similarly, we discussed in Laplace transform some constant into that. F of t is constant into Laplace transform f of t. Here also, the constant just you send that side t power n by n factorial. Now, similarly, the inverse Laplace transform 1 by s to the power of n plus 1 is t power n minus 1 by n minus 1 factorial. Right? Just you take the principle of this. The Laplace transform t power n is n factorial by s to the power of n plus 1. Similarly, the Laplace transform of t power n minus 1 equal to, what do you say, t power n minus 1 is equal to n minus 1 factorial by s to the power of n. Right? N minus factorial s to the power of n. T power n is n factorial s to the power of n plus 1. T power n minus 1 is it. So the, what is say, the inverse Laplace transform of 1 by s to the power of n is equal t to the power of n minus 1 by n minus 1 factorial. Right? And next, the Laplace transform of e power 80. What is the Laplace transform of e to the power of 80? 1 by s minus a. 1 by s minus a. Now, inverse Laplace transform 1 by s minus is e to the power of 80. Right? Next, the inverse Laplace transform 1 by s minus a is e to the power of 80. 1 by s plus a is e to the power of minus 80. What is say? The Laplace transform of e to the power of minus 80 is 1 by s plus a. S plus a. Then inverse Laplace transform 1 by s plus a e to the power of minus 80. It right. Next, by first shifting theorem. What is the first shifting theorem? Apply first shifting theorem for inverse Laplace transform. Right? What is the first shifting theorem here? What is the first shifting theorem? The Laplace transform. The Laplace transform f of t. In Laplace transform, I am writing first shifting theorem. F of t is f bar of s. F bar of s. Right? Now, the Laplace transform e to the power of 80 into f of t is 1 by, right? What is that? Or f bar of s minus a. F bar of s minus a. Here s is replaced by s minus c. E to the power of minus 80, s is replaced by s plus c. Right? S is replaced by s plus c. Now you see the Laplace transform of, what is the Laplace transform of cos 80? Cos 80 is s by s square plus a square. Cos 80 s by s square plus a square. Now the inverse Laplace transform s by s square plus a square is s by s square plus a square is cos 80. Simple. Cos 80. Cos 80. Right? Similarly, cos h80 and sin h80. What is the Laplace transform of sin h80? Sin h80 is, what is that? A by s square minus a square. Next, inverse. The inverse Laplace transform of 1 by s square minus a square is 1 by a into sin h80. Sin h80. Just a constant in right hand side. Right? Similarly, sin h80 and cos h80 also. Cos h80. s by s square minus a square inverse Laplace and cos h. Now using first shifting theorem, just replace s by s plus a when e to the power of 8 is there, coefficient. If coefficient is e to the power of minus 80, s is replaced by s plus a. Just you take this, the inverse Laplace transform of 1 by s minus a whole square plus b square 1 by s minus a whole square plus b square is equal to what you say. First you take the inverse Laplace transform 1 by s square plus b square is 1 by b into sin bt. 1 by b into sin bt. In place of s square, what is there here? S minus a is there. So just you add here e to the power of a to cos by first shifting theorem. S is replaced by s minus a. So e power 8 is add. Suppose in place of s plus a whole square is there, just to add e to the power of minus 80. Already we discussed in Laplace transform of first shifting theorem. Just here reverse here. Similarly here it's the inverse Laplace transform of s minus a by s minus a whole square plus b square. First you take the inverse Laplace transform of this. Inverse Laplace transform s by s square plus b square. What is this? This is equal to cos bt. Cos bt. Now in place of s, what is there? S minus a is there. Right? Just add here e to the power of at into cos bt by first shifting theorem. S is replaced by s minus a. Suppose s plus a is there, for example, s plus a is there. Sorry. Then you add e to the power of minus 80. So here e to the power of 80 into cos bt because s minus a is there here. S minus a whole square, s minus a, right, plus b square. Similarly, this s by s square plus a square whole square. You know the Laplace transform of t sin a t is 2as by s square plus a square whole square. What is that? Laplace transform of t sin a t is 2as by s square plus a square whole square. Now just you send the constant the right hand side. So 2as, right? So t by 2 is sin a t. Similarly, this t cube by 3 factorial inverse Laplace transform is power 4. And next, here inverse Laplace transform 1 by s plus a whole cube. So first of all, what is the Laplace inverse Laplace transform? Inverse Laplace transform of s cube. S cube is t square by 2 factorial. T square by 2 factorial. Just to uh, it is obtained from the t power n Laplace transform t power n, right? A general formula, right? Now in place of s, what is there? S plus a. So just to add e to the power of minus 80. E to the power of minus 80. So like this, from Laplace transform, just we are writing inverse Laplace transform deliberately, right? Next, some formulas are simple using formulas, simple problems here. Inverse Laplace transform 1 by s square plus 1 by s power 4 plus 1 by s square plus 4 s square minus 9 or minus 3 square. Just separately apply as a linear principle. Inverse Laplace transform 1 by s square. T. How? You know the Laplace transform of t power n is n factorial by s to the power of n plus 1. Right? T power n is n factorial by s power n plus 2. If you put n is equal to 0, what do you get? T power 0 is 1. So this is equal to n is equal to 0. 0 factorial here s power 0 plus 1. 0 factorial is 1. So 1 by s. So what do you say here? The Laplace transform 1 is 1 by s. Right? And similarly, if you put n is equal to 1, so the Laplace transform of t. What is the Laplace transform of t? N is equal to 1. So I put n is equal to 1. 1 factorial by 1 plus 1 s square. So Laplace transform of t is 1 by s square. Then from this what you say? Inverse Laplace transform 1 by s square is t. Sorry. So in place of s, what is there here? Nothing. Just 1 by s square is there. No need to apply this. So 1 by s square. So just you write down t here. T. Now inverse Laplace transform 1 by s plus 4 or 1 by s plus 2 square, just to write down 1 by s plus 2. So 1 by 2, this is 1 by s square. This is a print mistake. S square plus 4 square. S square plus 2 square. So 1 by 2 into sine 2t. Similarly, this, right? This is e to the power of minus 40, and this is 1 by s square plus 1 by 2 dc. Right? And inverse Laplace transform here 1 by s square plus 2 square, right? This is equal to 1 by 2 sine 2t. How it is possible here? Just you take the Laplace transform, sine 2t is, what do you say, 2 by s square plus 2 square, 4, right? Now just write down here the inverse Laplace transform 1 by s square plus 4 equal to, you send this at 1 2, here divides 2 into 1 by 2 into sine 2t. So here 1 by 2 into sine 2t. Similarly this s square minus 3 square, what is this? The Laplace transform sine h3d. Sine h3d is 3 by s square minus 3 square. 3 by s square minus 3 square. Now the inverse Laplace transform 1 by s square minus 3 square is 1 by 3. 1 by 3 into sine h3t. 1 by 3 into sine h3t. Like this. Similarly, find inverse Laplace transform of 2s minus 5 by s square minus 4 or s square minus 2 square. So just separate the fractions here. 2s by s square minus 4 minus inverse Laplace transform 5 by s square minus 4. Now 2 constant take out, inverse Laplace transform s by s square minus 2 square. Here minus constant, 5 is constant, 5 into inverse Laplace transform 1 by s square minus 2 square. You know s by s square minus 2 square is cos h2t, hyperbolic function, because we have negative. If it is plus, simply sin 2t. Here minus cos h2t plus cos ht, cos 2t simply. Hyperbolic here in the denominator s square minus 4. Here also 1 by s square minus 2 square sin h2t, right? Here you will obtain the numerator 2, so send to this side, so 5 by 2 sin h2t. Here also negative, so hyperbolic function, right? The hyperbolic functions, the symbol is here minus. So this is about inverse Laplace transform, some standard functions. And similarly, you take, find the inverse Laplace transform 2s plus 1 by s into s plus 1. How? How you find this s into s plus 1? Just you write down this, rewrite this fraction like 2s is s plus s plus 1. S is plus s is 2s by s into s plus 1. This is equal separate here fractions. The inverse Laplace transform of s by s into s plus 1 plus the inverse Laplace transform of s plus 1 by s into s plus 1. Separate the fractions. 2s can be write in the form of s into s plus s, s plus s. So s gets cancelled. Here s plus 1, s plus 1 gets cancelled. So then what do you get? Inverse Laplace transform, sorry, 1 by s plus 1 plus inverse Laplace transform of 1 by s. So here inverse Laplace transform 1 by s plus 1. So e to the power of minus t, because s plus 1 minus t, s minus 1 plus e power t, plus 1 by s is 1. Constant Laplace transform is constant by s. Right? This is the inverse Laplace transform given fraction. Right? And similarly, if you take find inverse Laplace transform 3s minus 8 is 4 3s minus 8 by 4s square plus 25. How you write this? To make it s square quotient is 1. S square quotient is 1 by take out from this denominator 4. So that is equal to, what do you get here? 3 by 4 inverse Laplace transform of, right? Inverse Laplace transform of s by, right, s square, here 4 take out, plus 5 by 2 whole square. These 4 gets cancelled, close bracket close. Similarly for the second one, 8 by 4, 8 by 4, right, 8 by 4 inverse Laplace transform 1 by, right, s square plus 5 by 2 whole square, right. So by 4 take out. So this is in the form of s by s square plus 5 by 2 whole square. This is s by s square plus a square formula. What is that s by s square plus cos at? So cos 5 by 2t. In place of a is equal to 5 by 2. A is equal to 5 by 2. Clear? S by s square plus 5 by 2 whole square means s by s square plus a square. So a is equal to 5 by 2. Here also minus 8 by 4, 1 by 1 by s square plus 5 by 2 whole square. So this is in the form of 1 by s square plus 5 by 2 whole square is, here 1 means you would get sine function, right? Sine 5 by 2t into 2 by 5 you get here, 2 by 5 also. You would get here 2 by 5 because 5 by 2 take out now. What is this actually? The Laplace transform of, I am writing Laplace transform. Laplace transform of, right, uh, sine 5 by 2t. 5 by 2t. What do we get here? Sine 80. Sine 80 is a by s square plus a square. So in place of a, what is it? 5 by 2 divided by s square plus 5 by 2 whole square. Yes, this is a. A is equal to 5 by 2. A is equal to 5 by 2. In place of a, 5 by 2 is equal. So then what do you say here? The inverse Laplace transform of 1 by s square plus 5 by 2 whole square is equal to, just 5 by 2 center side, 2 by 5, 2 by 5 sine 5 by 2 t. That's what I am writing. 2 by 5. Here 8 by 4 into 2 by 5. So 2 to the right 4. Or 4 1 is 4 to 4 by 5. Right, buddy? So 4 by 5 sine 5 by 2 t. This is about some simple functions inverse Laplace. Simple functions inverse Laplace. Just split into separate fractions, and the function or the fractions are more complex, then go to the split into partial fraction. These are some standard functions, no need to splitting into partial fractions, right? And here, so find find inverse Laplace transform 4s plus 15 by 16s square minus 25. First of all, you must make it s square coefficient is 1. So for that, take out 16 from the denominator. So that is, first you separate this fraction 4s by, first find inverse Laplace transform 4s by 16 s square minus 25 plus 15 into this 1 or 15 divided by inverse Laplace transform 15 divided by 16 s square minus 25. Separate this fraction. Now 16 take out here. This is equal to 4 by 16 from first fraction. 4 by 16 into inverse Laplace transform of this 4s. Na? So 4 take out here. S by s square. Here 25 you can write 5 by 4, or 16 you can write here 4 whole square. So 5 by 4 whole square bracket 4. Here 16, this 16 cancel. 4 square is 16. Here 16 is cancel. So this is equal h by s square minus 5 by 4 whole square. This is the first fraction. Next, place 15 by here 16, take out 16. Na? So inverse Laplace transform, what do you say here? 1 here. 1 by s square, right, minus 5 by 4 whole square. Right? Here s square minus 5 by 4 whole square. This is a minus, so you would get hyperbolic functions. So 4 4 just 16. This is equal 1 by 4 into 1 by 4 into inverse Laplace transform of s by s square minus 5 by 4 whole square. Right? Now, what is this? First you, here 15 by 16, 15 by 16, inverse Laplace transform of 1 by s square minus 5 by 4 whole square. Right? This is equal to 1 by 4 into, this is, you know, the Laplace transform of cos h at is s by s square minus a square. S by s square minus a square. Here you observe here s by s square minus a square. Here a is equal to what you say? 5 by 4, right? 5 by 4. A is equal to 5 by 4. So what do you say here? Cos h 5 by 4 t. Next, the Laplace transform of sin hat. Sin hat is a by s square minus a square. But the inverse Laplace transform, yes, send this side now. So the inverse Laplace transform of 1 by s square minus a square is 1 by a into sin h80. Sin h80. 1 by a into sin h80. Here what is a? A is equal to 5 by 2. Right? So here already here 15 by 16 into 1 by a. What is a? 5 by 4. So reverse 4 by 5. 4 by 5 into sine h 5 by 40. 5 by 40. Right? So here 5 3 are 15. So and 4 4 are 16. So 3 by 4. 3 by 4 sine h 5 by 40. This is the some standard functions inverse Laplace. Thank you.